Hi class, let's take a look at example 2. And in example 2, the main objective is to find the least common denominator. But in order to find the least common denominator, we're going to first talk about the LCM, or the least common multiple. So in this case, we're given two values. This would be 2 and 4. And let me show you one way to find the multiples and then the shortcut. So in this case, your multiples of 2 and technically 4 are going to be 2 times 1 is equal to 2, 4 times 1 is equal to 4, and 2 times 2 is equal to 4. We found a common multiple here, which in this case, it represents our answer. But notice that there is a pattern here developing, and you could look at 4 times 2 is equal to 8, 2 times 3 is equal to 6, and 2 times 4 is equal to 8. Here we have another multiple. However, we're looking for the smallest one of these two, which would be the value of the 4. So for our final answer here, let me just rewrite it as the LCM is equal to 4. And this would be the visual representation of the multiples. When we look at the shortcut, we're mainly looking at the prime factorization. So let me look at the prime factorization. And in this case, you're looking at 2 and the values of 4. So 2 is technically 2, since you can express it as 2 times 1. And 4 is equal to 2 times 2, or 2 to the second. And then the LCM in this situation, it's going to be the maximum of 2's that appear. And you're looking at the maximum that appeared here and that appear here. So in this particular situation, the LCM is the maximum of the 2's, which will be 2 to the second, or the values of 4. Which is what we concluded above by looking at the multiples. Let's take a look at another example where the numbers are a little bit larger. And in that case, we're just going to be looking at the prime factorization. So for example, let's take a look at problem 2. And the prime factorization it's going to be as follows. So we're looking at the values of 10. This is equal to 2 times 5. And technically 13 is just the values of 13 because 13 is prime. So in this case, the LCM is equal to the maximum of the 2's. This will be 2 because it only appears once. The maximum of the 5's, or 5, times the values of 13. Please multiply that. I'm getting 2 times 5, that's 10, 130. And then as you're looking at these, even though 10 does not contain a 13, in the LCM, you have to look at all the primes. If there's a tie, you pick the biggest one of the 2's or the 5's that appear. That's actually it for problem 2. Let's move at problem 3, which has numbers a little bit larger. In this case, the prime factorization for the values of 36, this is equal to 6 times 6, or 2 times 3 times 2 times 3, or 2 to the second and 3 to the second. That would be the prime factorization. For 63, we can break it down as, let's see, 3 and 21. And this will be 3 times 7. So this will be a 3 to the second times 7. Let me double check that. And this is our prime factorization. Now, as you're looking at the LCM, there's a couple of ties here. So your LCM is going to be maximum of the 2's. This will be a 2 to the second. Maximum of the 3's. This will be a 3 to the second. And then the 7. So please evaluate that. I'm getting 252. That's actually it for these problems. I'll put the other ones which actually deal with the common denominator in another video.